Hi, this is Amy.
And Melissa. We are a couple of retired Texas teachers who are CALTs, Certified Academic Language Therapists. We started our own businesses, and now we have a podcast called The Dyslexia Duo.
So join us for our informative podcast, where we'll delve into dyslexia, covering the topics that affect parents, therapists, teachers, practitioners, and anyone who wants to learn more. We'll guide you through everything you need to know, from the first signs to the intricacies of dyslexia curriculum placement and beyond.
This season, we will cover the referral process, what to expect when your child or student is dyslexic, the generational impacts of dyslexia, and how to support those affected.
Come join us! Hey, Melissa.
Hey, Amy.
Okay, so we have a very busy person with us today. She has been really hard to hammer down and get an interview with, but we all persevered, and here we are today. So will you go ahead and introduce yourself to everyone?
Great, thank you. My name is Fumiko Hoeft. I am a psychiatrist by training, so I went to medical school, and then I got my PhD in neuroscience. And I came across dyslexia, and I've been studying the neuroscience of dyslexia, among other things, since. My title is Campus Dean and Chief Administrative Officer right now at the University of Connecticut, in particular the Waterbury campus. And I am a professor of psychological sciences. It was my dream to work in a non-medical school environment once. So I have been working in a non-medical appointments in education, in neuroscience, in computer science, and also in the medical school in pediatrics and psychiatry, because all of these things, as you well know, are related to dyslexia. And I also have appointments in other places like Keio University in Tokyo, and then soon to start at Yale University and so on.
Wow. Yeah, every time I talk to you via email, you are in a different country. Every single time. Every single time.
Probably true.
So let's just kind of jump right in. So what led to your career? What got you to where you are now?
So when I was younger in elementary school, I wanted to be a physician. I wrote in my graduation book, I wanted to become a physician and help the poor and underserved people. So I wanted to go to developing countries. I went to medical school in Japan and I became a physician, but then I got fascinated by the brain. So I became a psychiatrist. And then I thought, I'm going to learn about research a little bit so that I understand how these interventions and medications and others are developed. So I came to the States many years ago, and it's been 25 years since. And starting from psychiatry to depression, I got into cross-modal integration, which is how sound and vision interacts. And I was researching that at Caltech, the California Institute of Technology. Then I sort of missed the more clinical aspect, or the real world sort of aspect. And that's when I came across dyslexia, and I moved up to Stanford in California to do research with a professor called John Gabrielli. And that's how I became fascinated and started research in dyslexia.
Amazing.
So there was no family link or anything that took you down that path or anything like that. It was just truly your own discovery in your own research through your education.
No, that's a very good question. So first, I thought it was completely independent, random, meeting this professor at Stanford, and that's how I got into it. Or that is one story. But the interesting part is that my younger son, who was born after I started dyslexia research, has dyslexia.
Oh.
So he had early signs of dyslexia. And of course, so everyone told me, just like every physician thinks that they have every disease, they thought you're labeling every child with dyslexia or ADHD or something like that. I spent years convincing my husband that, no, I know this because I know this, and I've been doing research on this. So this is one area where you can trust me. And then, but he blamed it on himself that he wasn't reading enough to the second child. And so it took me more convincing of my husband, and years of convincing, even though I saw signs, to convince him that getting interventions is not outsourcing childcare, and it's not early intervention is important and early assessment. So that's one kind of other connection that happened afterwards. And of course, being, as it often happens, when your child is identified, then you look back at yourself and then you realize, oh, maybe I had very similar symptoms. So I really related to my younger son because that is completely me when I was younger also. Everyone gave me an out when I was growing up because I was born in Japan and no one still believes in dyslexia in a way, or a lot of people still don't. But also because I moved around countries. So you told me that I'm in a different country every time, but I was moving around a lot as a child also. So I came to New York, I went back to Japan, I went to London, then I came back to Japan. So everyone thought that it's an English as a second language phenomena. And they said, there's no way that you have dyslexia, you can read, you can study. And so then, but I realized that after 25 years being in the United States, people started saying, I think maybe you were right because no one has that after 20 years of being in one country. So that's a long story again of my background and connection.
That's fascinating. So how did you convince your husband, knowing what you know about yourself, how did you convince him about your son and noticing that you see these characters?
That was the hardest part. He wouldn't listen to the scientific evidence, and he just, because he's an avid reader and it comes so naturally to him, he couldn't believe that there were people who couldn't read or didn't want to read. And so that was really challenging. I just said, it doesn't hurt. It doesn't hurt to get extra support. It's just kind of like tutoring or other things, and it's not a bad thing. And finally, we were able to convince him end of kindergarten. So it was still early on compared to most families. So we were very fortunate that way.
I do feel like that's a challenge that I go through with some of my parents, that they don't want to go through the testing process because they don't feel like either one, that they want the label, or two, they don't feel like it's dyslexia because they can read a little bit. They can read some, so they don't feel like it's dyslexia. And like you said, they might think laziness or just that inability to make that connection because they didn't ever have that problem.
Yeah.
And I'll be honest, whenever I've had to do like IEP meetings or ARDS or anything like that, it was always the father who, it almost like I had to filibuster, and talk about all the things, the quantitative and qualitative data that I had. And it was always the dad that would go, well, I had to work that hard and I'm just fine, that type of thing. And you're like, why would you want your child to work so hard like that?
That's true. Maybe there's a link with, I often think it's very similar to, when you get lost in a unknown town and you want to go and ask for directions, and men never want to go for your ask directions. I feel like maybe there's some biological overlap there, some genetic connection there.
Yeah, definitely. I definitely feel that. So talking a little bit more about dyslexia, have you found some genetic links to dyslexia? We know it runs in families, but that's about as deep as I can go with the genetics. Is there any genetic links that you know of with dyslexia?
Yes, no, absolutely. So there are genetic links and it runs in families, but it's not very simple, as you know, because otherwise, if it's a dominant trait, then you would see it in every family member, for example, and going down the linkage in particular family members. So now we know that it's complex. So it could be called a complex disorder, polygenic inheritance, or polygenic. Poly means multiple and genic means genes. So there's multiple genes that are involved. And this, as a result, becomes more complicated. And it's not that if you have a parent, you're always going to have a child. So then the transmission is intermediate. So medium, it's not 100%, it's not 0%, it's somewhere in between because there's multiple genes that are involved, which is called polygenic. So there are a number of dyslexia risk genes that have been identified many, many years ago. But most of the molecular geneticists, and I'm not a geneticist, but now they believe that it's much more complex. So you can't just say, oh, I discovered the dyslexia risk gene. And probably 10, 20 years ago, we saw a lot in New York Times and other places that Another researcher found a genetic risk gene for dyslexia, and someone found one for autism and schizophrenia, and much fewer for dyslexia, and probably because of education and a lot of writing systems and different complexities make it really hard. And not as many researchers study the issue probably also. But now that it's considered more, as there's more of these common variations that you see, and many of those are involved, and each of these have really small, tiny sub% sort of effect sizes, and they combine, and then you have these 40 to 70% genetic risk if you have a close family member with dyslexia.
40 to 70%.
Probably yes, but I think, yes, and many people, and it depends on, for example, the writing system. It might depend on the family background and support system they've had, and a number of factors, and protective and resilience factors, and a number of things, which also might be biological and others, but all those are combined. And so it ranges quite widely depending on how you look at it.
Wow.
That's so fascinating. And I wonder how they found how do all the researchers, I know you're part of that, how do you guys isolate those risk genes?
Risk genes. So I'm not a geneticist. I'm not in the best place to talk about this, but so originally people did more found family transmission patterns saying, oh, you have a family member, you have a family member, you have a dad, you have a mom, and so on. And then people started studying twins, which is a common way to study how much there's a genetic component to this. You study identical twins, you study fraternal twins, and you look at the differences, or siblings. This is about 50% overlap in genes. Identical is almost 100% overlap. So then you could do some statistics to look at the differences and see what it is. In terms of the actual biological genes, then you would take spit samples or blood samples from a large sample of individuals, and then you look at the pattern and what individuals have in their genetics unique pattern when you have identified individuals with dyslexia. So it's a power issue, and most of the earlier studies are much smaller participant sample. Even though you hear the number of thousands, you think it's large, but it's not large enough to find these kind of small effects. So if they found one, sometimes and often it's hard to replicate when you do it in hundreds of thousands of individuals, which is now becoming more of the norm.
Oh, wow.
And the cost coming down also.
I can remember, it's got to be 15 years ago, I had twin girls that were both identified as dyslexic. And just because of how I had to pull them for therapy, they came at the same time. They were the same grade level, same time. I wasn't real hip on them being in the room at the same time, but it seemed to work out. But their difficulties in dyslexia were different from each other, which I thought was interesting. Of course, they both had the written expression piece, difficulty with spelling, but one was faster with decoding and sight words than the other one was. It was interesting to me. It was really
Isn't it interesting when you look at families and siblings, you would think, even just looking at regular personalities, if you have two kids, they're never the same. One's more organized and one's disorganized, and one's happier and one's crankier maybe. And so even with dyslexia, there's so much variation. And now, just like this polygenic thing that we talked about, people often use the word multifactorial models. And so with autism and others, it is multifactorial, and that it could be biological, and many biological, genetic, and other kinds of biological impact might have, and maybe even prenatal environment might have some impact. There were old research and many people don't believe it's true, but prenatal inflammation, and there were all these things that researchers were finding and talking about many decades ago. It's a controversial topic, but there are some things that people have found in the past in autism as well as dyslexia and others. And then there's all these environmental, schooling, other effects as well that could impact. And so that all makes it complicated in terms of its expression and complex. So even if you're identical twins and sharing almost all the genes, the environment is not all completely shared, even though you live in the same home by the time you exit the home, or maybe one's more interested in something else. So It makes it very interesting and to see how different each child is. And it's fascinating to hear about the twin story too.
Yeah, I had many a person saying, "You're missing an opportunity to write a paper."
That is true. Case study.
So can you share with us, with all of your vast expertise, can you share with us the definition of dyslexia as you see it with all of your research?
So dyslexia definition is, everyone knows what dyslexia sort of is. It's a challenge in reading, dys, and then lexia. So that part is easy. And then when you get to the specifics, it's very, very hard. And there's been many definitions and many groups depending on their interest or professional organization that's coming up with it. So for example, the IDEA and the 2004 reauthorization is more of an education-oriented diagnosis or diagnostic or identification system. And it's been around 20 years, but I think that's mostly still what it is now. I was just reading about it and comparing it to a most recent research paper that came out last year from the Florida Center for Reading Research, FCRR, and they wrote a consensus sort of paper. They don't give you a small cheat sheet of the newest definition, but I was just reading through it the other day, and it's very interesting, and I'll point out some of the evolution. You would think that in 20 years, it would have made a major difference with all the MRI and genetic research that's been exploding. Surprisingly, you might be underwhelmed by the difference or conservativeness of the modification that's being proposed. But then there's also the DSM-4, which is the medical Bible sort of for diagnosis of neurological and psychiatric conditions. And dyslexia is not used as a label in there, but specific learning disorders is in there. And then the reading subtype will be equivalent to sort of dyslexia in a way. And they have a different agenda in terms of why they're diagnosing it certain ways, because they're aligning it with every other neurological and other biologically known cause and known non-cause disorders all mixed together. So makes it challenging. But what they said, I'll just get to some of the things that was said in this recent paper that I was just reading by Hugh Katz and his colleagues. And I think persistent difficulties in word reading, spelling, decoding, that's still there. And as expected, there is a focus on word reading. And then also that it is a neurobiological condition, neurodevelopmental condition, that's still there as well. Some of the places where they deviate is, in the previous one, they were emphasizing phonological deficits, phonological problems as a major cause of dyslexia. That is now de-emphasized, and people use the word has a multifactorial causal basis, like we just talked about, multiple things. Of course, the environment doesn't cause it, but it could make it worse. It could make it different. And so all these neurobiological, cognitive, and environmental influences impact its cause and expression of dyslexia. So that's one major change that's being proposed. And then it's also on a continuum more. And everyone knew that it's on a continuum. Some people are reading less, has some challenges, and some people have really severe challenges. So that's on a continuum. And everyone always thought so, but there is much more of an emphasis on that now, because people used to, and we still do, dichotomize, oh, you have dyslexia, you're not dyslexic. But there's a lot of this gray zone. And of course, if you're younger, it switches, because testing, as you well know, is you use a cutoff point and you look at the whole thing, but still you use a cutoff point, and it could slightly change over time. I think there's also an emphasis of context. So for example, the writing system, if you're from a Spanish speaking background or not, so those cultural backgrounds might be different. Of course, cultural background can impact whether or not the parent goes or the child will express or advocate for themselves, and that would be different also. Educational system, whether you went to a very supportive school that uses the latest intervention strategies or literacy instructions, and socioeconomic backgrounds, those could all impact on top of the biological factors. And I think the one or two final things that are emphasized in this paper that's, I think, is interesting is it happens at all intelligence levels, and people know this and say this, and research have supported this, but there's still this discrepancy. Let's look at, you have to be sufficiently or unexpected compared to other cognitive abilities. And that's in the IDEA, for example, that many people feel should be de-emphasized. And then one of the new emphasis is on the psychosocial consequences. Because if you don't get early intervention, if you're depending on your environment, there's these social emotional consequences like depression and anxiety. And these are substantial for families as well as children. I know from talking to many families that they would like to send their kids to an LD school or learning disabilities or dyslexia school because they know that they learn to advocate. They know their child is much happier and they're less anxious, for example, with a lot of peers around them. So there's a focus on the psychosocial consequences as well.
Wow.
I think that my question that came out of what you were speaking about, among other things, but what I want to kind of hone in on is you said PA was kind of de-emphasized. In my experience, when I've worked with my dyslexic students, I see a lot of times a phonological memory is more of the problem, less so of the memory seems to be a big part, but also the working memory seems to be a big component in what they struggle to overcome. I definitely see the spelling weaknesses, see the phonological component as well to some extent, but I feel like the biggest hurdle when they need to overcome their dyslexia is revolving around their working memory, having those challenges.
I absolutely agree. And look at my younger son also, that's where we first noticed. And that's what I felt like was impeding on his progress for interventions. And so I completely agree with you. And just so we know, at least in the English language, phonological processing is still a major risk factor, and the importance has not gone away. But I think the overemphasis and being like a single gene disorder, a single phonological processing creates dyslexia, that has been lessened. So what you said about memory, working memory, and these aspects, as well as other language and other systems, are very important as well.
We'll be right back after a word from our sponsors.
Hi, this is Melissa with Kids First Dyslexia Services. I am excited to share with you my private practice. Kids First Dyslexia Services is a private practice that specializes in dyslexia therapy. Each one-on-one session focuses on instruction specific to your child's needs in a nurturing environment that develops self-esteem, builds confidence, and fosters a sense of accomplishment, resulting in happier kids with higher levels of achievement. We provide a professional, personalized experience, always putting the child first. We value the relationships with both our students and parents because strengthening skills and overcoming hurdles to achieve desired goals and success is a team effort. For more information, please visit www.kidsfirstdyslexia.com. That is www.kidsfirstdyslexia.com.
Hi, this is Amy Rodenroth, and as part of the Dyslexia Duo Podcast team and owner of Discovery Dyslexia Services, I want to talk to you about my business. Our COUT-trained team offers expert virtual or in-person therapy located in Prosper, Texas, using proven dyslexia curricula like Take Flight, Build, MTA, Alphabetic Phonics, and Reading by Design. We also provide crucial independent evaluations and advocacy services. Don't wait. Empower your child today. Visit www.discovereed.com to learn more. That again is www.discoveread.com. Discovereed, covering all your dyslexia needs. Let's return to the show. I think that's interesting that we were talking about the phonological aspect, because I can remember years ago, and a little knowledge can be a little dangerous sometimes, that in a district that I was in, and this is pretty early on, when we would do like a C-top, and if they had average scores in the C-top among the three subtests, the elision, blending words, and phoneme isolation, those three areas, we would stop because phonological awareness was in place. So there must be something else going on. I mean, we know that that's the most sensitive remediation. A lot of like RTI that's out there is offered at the phonological awareness. So that might get remediated, but there's not necessarily carryover into other areas, which kind of leads me to my next question. I get a lot of like college referrals at my private practice. Can you assess this college student? Because there's a concern of stealth dyslexia. What is stealth dyslexia exactly?
So stealth dyslexia is interesting. So some people almost use it synonymously to twice exceptional or 2E students. 2E is a broader term because, of course, it's not just about dyslexia. It could be about autism and ADHD and others. But basically, you have strength in one area and then you struggle and have major challenges. So if you take that to dyslexia, then it could be talents in some area and challenges in others. But my understanding of stealth dyslexia, and it's not an official diagnosis, and it was first discussed by the EDs. And so not everyone uses, and especially in research, not many people use this term. I've used it in one of my papers, and we use it very specifically to talk about the discrepancy between reading comprehension. So typically the cascade of events would be that you have reading challenges or decoding challenges, and that could lead to whether it's not liking to read or problems with fluency, and all those kind of things could impact reading comprehension. So you would think that reading comprehension heavily correlates with decoding. Of course, most people don't think that's related to the cause of dyslexia or the main symptom in a way of dyslexia, characteristic of dyslexia, but there's a natural consequence because it starts from decoding or further up from biology. And so my definition of stealth dyslexia is reading comprehension, decoding discrepancy. And we did a neuroimaging study several years ago, maybe almost 10 years ago now. Everything seems like several years ago, and you look back and it's like 10 years ago. So we did a study on this, and some people use the word resilient dyslexics. Maybe in the paper we use the term resilient dyslexics, but we meant that fits the stealth dyslexia category, which is reading comprehension, decoding discrepancy. So we looked for what's the brain signature behind this, and how can we sort of predict how well they're going to do depending on their characterization or how their brain looked. So we did a study on that and followed kids for a while.
Wow. So what did you discover from that? So
the simple answer is we found that this area in the bilateral, but more on the left side, the dorsolateral prefrontal cortex, or some people call it prefrontal cortex or DLPFC, its area was important and was sort of responsible, meaning correlated heavily with this amount of discrepancy. So it wasn't correlating with decoding, it wasn't correlating with reading comprehension necessarily, and it was really correlating with the differences. And so that region is often important for executive function. And you spoke about, you mentioned work and memory, but executive function, learning, these aspects, what makes human, part of the biggest part of the human neocortex area. And that area was most related. The other interesting thing that we did was we took that part of the brain in younger kids, pre-readers, and then try to predict who was going to be most resilient also. And that area was also most predictive of who became most resilient and defined, or stealth in a way.
Okay, so I just want to make sure I'm understanding you correctly. So basically, there's a discrepancy between the way a person can decode versus the way that they can comprehend. So they might get remediation in the decoding, but still have the problem in the comprehension.
Well, stealth dyslexia is the opposite, right? So somehow they are very good at reading comprehension despite having challenges in decoding.
Okay, gotcha.
And I think that's interesting because, when the kids are little, like kinder, first and second, we hear a lot of them, they're reading out loud in classes and the teachers hear them read out loud. But when they get to third grade and beyond, there's not as much reading out loud. And so I can think of, if I think back to my past, I can think of teachers going, well, he's comprehending, he's understanding what he's reading, but what does it sound like? when he's reading it, and how many rehearsals is he taking to get to that comprehension. I think
Yeah.
that's something that at the secondary level that needs to be considered. I think a lot of our kids at the secondary level get missed.
I agree. And I think related to what you were saying, it's interesting because many of the quick screeners that school has implemented, and of course, with the legislation changing across the states and everyone advocating, it's changing rapidly. But a lot of the quick tests are often reading and comprehending. And then you think, okay, if you can comprehend, probably everything else underneath it is fine. But then many of these children who go unidentified, like maybe these stealth individuals, would have stumbled later in life because until maybe grade 3, you could kind of read from context or other things, and then you can't really decode and understand the structure of sentences. And when it gets to be more complex, from changing from learning to read to reading to learn, then that's where things start falling apart.
Yeah, absolutely.
So I'm thinking back to some of our conversations just a little bit earlier. I was thinking about how a dyslexic brain reads and how that differs from a non-dyslexic brain, and thinking about how you were talking about convincing family members that this person looks like they have dyslexia because of X, Y, and Z. So what would that look like if we wanted to help them compare and contrast a non-dyslexic brain versus a dyslexic brain and how it reads?
So there's a simple answer and then there's a complicated answer, but I'll start with the simple answer. So the simple answer is there's been decades of MRI research, and before that, so now there's tools like functional MRI, where you can look at the function using an MRI machine, or you can look at diffusion imaging, which allows you to look at highways, sort of white matter fiber tracks between different parts of the brain, gray matter, which is like different cities, and you can look at efficiencies. You can also use other tools like MEGs, EEGs, electroencephalogram, you might have heard of more, magnetoencephalogram, maybe less, and many other tools to look at various aspects. You can look at neurochemicals and others also. And before that, people relied on, for example, animal models, or look at lesion patients when they suddenly lost their ability to read in these rare cases, and people made observations and they were called dyslexia, for example. So that's many years ago. So you would think over the past many decades of this kind of research, and especially recently, now that anyone can go in the scan, most people can go inside the MRI machine and come out after an hour, you have a brain map and so on, that we would have a clearer picture. So the original, more optimistic understanding that you might see in a book chapter or some newspaper article will be there's several parts of the brain that's important for reading. Left hemisphere tends to be more important for language in general in most people, and that is still true. But of course, both hemispheres process language, but in different ways. And the area above the ear on the left side, I'm just doing a cartoon version, so I apologize, and a little bit towards the back, it's called it took me months when I first got into this field to understand brain parts, because this area that I'm talking about above the ear and behind the ear a little bit, a lot of people call it the left temporoparietal region. Some people might call it temporoparietal junction, TPJ, parietal temporal junction, PTJ, and then you might call it by the gyrus, which involves some of the ingulus gyrus, some of the posterior superior temporal gyrus, and then the supramarginal gyrus. So I'm just talking about this one area that people think is important for phonological processing and decoding. And people use so many words. It's part of the parietal lobe and the temporal lobe. And I got so confused, it took me months. So we start with the visualization of where it is above and behind the ear, sort of. And this area, we'll call this TPJ for now, is often important for phonological processing, decoding. There's some vocabulary possibly areas as well, and sentence comprehension, but just briefly, it's more of the phonological decoding area. That has been shown over and over again to be dysfunctional, whether the activation is lower or reduced activation, and so on. And then there's another area more towards the back and bottom of the brain that's underneath is the left occipital temporal region, OT region. And sometimes that's another one where everyone uses different words. Visual word form area, I'm sure you heard about, and that's a very specific area. Fusiform gyrus, and a lot of other different names. So that one is more important, as you can imagine, as for the visual components. Mm-hmm. So it's sensitive to words more than fake words. It's sensitive to visual things. And that occipital temporal and the temporoparietal region above the ear is the one that communicates and is very important for this, what some people call the dorsal pathway. And there's all of these jargons about fiber names, but that kind of two areas have been thought to be key. And then there's a number of other areas, like you may have heard of the right hemisphere is often used as compensation. So when you're younger, the cartoon version again of it is that when you're younger and before you learn to read, and as you're learning to read, it's bilateral. So you use both sides of the brain, and it becomes more and more heavily geared towards the left. So the seesaw kind of tips over to the left when you become a more efficient and fluent reader. And so as an inefficient reader, you might be using that right hemisphere more to support the left system. So that's one anecdote. I sort of believe that, but it's never the same region. When everyone says right, but right is a big part of your brain. It's half of your brain. And so I think it makes a big difference if it's in the front or the top or the back, and it seems to point to a lot of different areas. But the right hemisphere, we've shown that also another area that people talk about often is the inferior frontal or the frontal region. It's different from the stealth region. It's more the Broca's area or the language area, precentral area. We think it's important for articulation when they're compensating. We think it's the articulatory area. So, for example, when you're a younger child, tell me if you want me to stop because I talk a lot.
No, this is so informative.
This is great. And I'm probably going to go back through and take more notes because I'm taking notes, but at the same time, I'm like, I have to stop and process.
Yeah, I have to listen to what you're saying. Yeah.
So when you're a child, you over or covertly articulate, and I'm sure as a clinician, both of you kind of have seen this, that they're articulating or whispering sort of when they're reading. And then as an adult, normal sort of adults will lose that ability or not do that because it doesn't do much to them. And it's actually a strategy that helps kids learn to read. But then there's clinically probably, and I'd love to hear what you think, is that adults with dyslexia continue to use those articulatory strategies. So they will continue to articulate covertly or overtly. And what this imaging study, we did a couple of these to look at this, and we found that it seems like the network that's often used for compensation is in this frontal or frontal striatal sort of frontal network that's important for articulation. And that seems to make sense with their effortful strategies to articulate even as an adult with dyslexia.
Wow. That's fascinating. I have not worked with adults with dyslexia, so I don't really have a lot of experience into that. But I do know that in my own medical journey, and I've shared this a little bit, I don't want to go into it too much, but I did have a type of stroke and it caused some damage to a parietal area, one of the cortical veins in my parietal lobe. And I do notice that sometimes words just totally change when I'm reading. And I think, is this what dyslexia is like? Is this what the kids go through? I know that it doesn't make sense in the sentence. So I go back and I see, I totally just read that word wrong. It was completely wrong. And it's because I couldn't decode it. It was just, it totally changed form. It was the strangest thing. So with that said, that's the thing I notice now when I read. Sometimes I do some of that talking through, am I reading this right? Just making sure that I'm doing it right. So that is very interesting about the auditory component.
So when you speak of covert articulation, would that be like an adult who's moving their mouth while they read?
Yes, but it could be without even moving their mouth also. Some people talk about this internal rehearsing. So it could be a number of things, but that would be a major way of doing that also.
My father-in-law is dyslexic, so I've seen him do that when he's really trying to comprehend something, like directions or something like that.
That's really fascinating.
Yeah, that's interesting.
So as far as auditory processing, I've been really fascinated by this as far as how it affects people with dyslexia. I watched another continuing education gentleman by the name of Dr. Lucker. He's a speech language pathologist by trade, but he talked about auditory processing integration disorder and how a lot of kids might have dyslexia and this auditory component, and it's more just the integration of everything all together sometimes is too much for them. So I just wanted to know a little bit more about your input on, can auditory processing and auditory processing integration disorder be intertwined with dyslexia, and can dyslexia be an integration disorder of sorts?
Oh, that's very interesting. So there's a lot of different pieces to this that I want to answer, but I will mention as a caveat, I'm not an expert in APD or auditory processing disorder. I've done in my Caltech days, my expertise was in auditory visual integration, and there seems to be a resurgence of interested in that, especially in the area of dyslexia. So I'm interested in the integration piece. I'm also interested in the auditory processing disorder piece because it does heavily overlap with dyslexia. And so all those are interesting. So I'll just say APD for now, if that's okay with you. APD or auditory processing disorder, yes, it does heavily overlap. It's thought to be about up to 50% overlap in the identification. So those with APD are likely to be identified as dyslexia. If you look at some of the tests that you use for APD, it's looking at a different level in a way. It's more like dichotic listening or some listening tests. They don't have hearing problems necessarily, but they have these complex auditory processing that then shows a difference. But it's very interesting because if you take any of those tests and look at how researchers have done research in dyslexia, often those tests have been used in research in dyslexia, and people do find differences. And it might depend on the writing system and others, but I had a postdoc from Europe once, from Leuven, and she's a professor there now, but she did a lot of work in this area of these auditory characteristics like rise time and other things that I won't go into each of the details of these measures. But what one might say is that, well, I might say something controversial, but I'll say it anyway, that it might be talking about the same thing for a lot of people, meaning that, and of course someone will say, well, APD, 100% of those don't develop dyslexia, but as we know that it's a polygenic condition, multifactorial condition, dyslexia. So I do believe that it could be one major factor that could lead to dyslexia. So people will use the word often comorbid with dyslexia, or they might co-develop dyslexia, but it might be a stronger relationship than that, because this auditory processing, a lot of the tools that they use to diagnose APD does correlate with phonological processing, and then there's an overlap of dyslexia. Some people will say there's subtle differences and biological differences. I think there's not enough research to really look at the differences, but I do think that looking at the link between APD and dyslexia will be very helpful to understand the biological kind of mechanism underlying dyslexia. And then you brought up the integration issue.
Yes.
I think integration and auditory processing sounds like a very different thing, and they are, but mechanistically there's some overlap. And I said I used to study auditory visual integration, how sound and speech integrate. Both of this, phonological processing and auditory processing, requires very fine temporal tracking in the brain, if that makes sense, right? Because auditory signals are really rapid. And auditory visual integration requires very fine temporal timing of things, because if you miss it a little bit, so for example, have you heard of the McGurk effect?
I have not.
So if you can look up McGurk effect, there's some demos on YouTube and a lot of this. So it would be interesting for maybe we often use it for things like science outreach for kids, because you might hear one thing and you might see one thing. So if you hear a ba, I'm going to get this wrong, but hear a ba, see a pa, then you're going to process, you think you heard something else because the visual cue is strong and the auditory cue is not strong enough, and they merge and it creates you really think you heard something else.
Okay.
So it's very interesting. There's other more basic illusions that my Caltech lab, my colleague of mine she was a postdoc there, but now she's a UCLA professor. But what she did was this auditory visual illusion where you can see a flash a number of times. So you see a flash on the screen like 2 or 3 times, 3 times, say, and then you hear a clap 5 times. Then you're almost always going to say that you saw a flash 4 times, even though it's definitely giving. If you had no sound, you're never going to get it wrong, and you're going to say 3 flashes. But once you hear 5 beeps to it at the same time, you're going to think that it's 4 flashes, which is very interesting. And so you can look those illusions up. But so we were studying these kind of things. I had my own illusion, but I'm not going to bore you and talk about my own illusion. It's not named after me, by the way. It wasn't that famous. So everyone was discovering these illusions and identifying the mechanism as a way to understand the brain. So that's what this lab was doing at Caltech. So getting back to auditory visual illusion, so unless the timing is perfect, you're not going to perceive that as integrate that information. So auditory visual information integration requires very fine integration or temporal sampling and parsing of information in the brain. And then auditory does as well, and that relates to phonological processing and so on. And so we proposed this hypothesis. I'm going to advertise a little bit about our hypothesis. Several years ago in 2017, now a long time ago, I guess, it's called the neuronoise hypothesis. And what we proposed was there's some individuals with dyslexia might have increased noise in the brain. Some noise is good to increase the signal detection, but if you have too much of it, then it becomes a problem. Then that creates a problem with oscillation or synchronizations between different parts of the brain. And it might increase neurochemicals that would offset some of these excitatory and inhibitory balance that is required in the brain. And that could cause timing problems, which could lead to phonological processing problems or cross-modal integrations. So that was a long way of saying I think those are very highly linked.
Noise in their brain, is that like tinnitus? Is it noise from having too much fluid in your head, from needing tubes in your ears, things like that?
There's many different kinds of noise, but the one we're talking about is not related to that. It's more about at the electrical level inside the brain, from cellular and communications between different parts. So you can't really hear it. It's not audible unless you connect your cells to an amp. Maybe you can. But it's about synchronization and too much noise, meaning, so if you have a fairly regular pattern of neurons spiking, for example, if you have high neural noise, it will be more jagged and be unpredictable. Yes, I'm not going to go too much into details because I can nerd out and talk about hours for this and get too uninteresting. So I'll leave it at that. But it's stochastic, more unpredictable kind of noisy, like you would see when you see a radio signal going zigzag and everywhere.
So then they can't focus on the thing on which they're supposed to focus their hearing.
It might relate to attention. It might relate to integration of information, because then you can't properly synchronize between different parts of the brain if you're randomly firing at random places and in a random way. If that makes sense.
A lot of sense. That's really cool. Thank you.
That is very interesting. And I'm going to have to listen to this podcast probably 3 times.
Yes.
To kind of pull it together a little bit more.
Well, you know what? We're actually hoping that we can get some continuing education credits for our association of people. For
ALTA. Yeah.
Yes, for ALTA. So
that's great.
And this is a great reason why. I mean,
great one for them to listen
so much.
for some CEs. But that's the hope. We're hoping they approve it. This completes part 1 of our conversation with Dr. Fumiko Hoeft. Join us next week as we conclude our discussion. The Dyslexia Duo Podcast hosts are Amy Rodenroth,
Melissa Dean.
Our producer is Greg Rodenroth.
You can find us on Facebook at The Dyslexia Duo.
Email us any questions or comments at thedyslexiaduo@gmail.com. neurodevelopment.com.
Awareness is so important. Share this podcast with your friends,
Family,
and teachers.
thanks for joining us.
Bye.